Today I'll be showing how to use the Qubit. So here I have my Qubit tubes, and I also have my Qubit reagents here. So to use the Qubit, especially the Qubit reagents, you have to let it sit at room temperature for at least an hour, 30 minutes to an hour. Then you should also avoid exposing the working solution to light because it's very sensitive to light. So first I'm going to start by preparing the standards. So since I have 8 samples, I'm going to need 8 Qubit tubes plus 2 for my standards. So I'm going to need in total 10 Qubit tubes. If I'm working with or I want to quantify like 5 samples, then I'm going to need a total of 7 tubes. For 3 samples, I'm going to need a total of 5 tubes. But in this case, I'll be needing 10 tubes. So next thing I'm going to do is to label the tubes. So here I have my 10 Qubit tubes. So always avoid labeling on the tubes because it's a very sensitive tube, like the machine is sensitive as well. So always know but always keep in mind which is which tube is which, as to not to mix your samples. So first I'm going to start by adding 190 microliters of the working solution to the tubes meant for my standards. Start by adding 190 microliter of my working solution to the standard tubes. So if in any case you can't protect the working solution from light, you can always make an aliport in a tube like this, covered with foil. This way you protect the whole your initial stock. So I'm going to start by adding 190 microliter of my working solution to the standard tubes. So next thing I'm going to do is I'm going to add 10 microliter of my standards. So I'm going to add the first standard, which is the standard B. It's labeled on the tube. So I'm going to add it to the first tube, my first standard. So I'm going to add 10 microliters of it. And also I'm going to add 10 microliters to the second one, my second standard, which is labeled C. So I'm going to allow to sit for approximately 2 minutes in under room temperature. So while sitting for 2 minutes, I'm going to add 198 microliters of the working solution to the other tubes. Or I can also use 199 microliter of the working solution to the tubes meant for my sample. It's because I can always use 1 to 2 microliter of my sample in this case. So, but for this, I'm using 2 microliters, so I'll be adding 198 microliter of my working solution. When I'm done adding 198 microliters of my working solution to my sample tubes, I'm going to add 2 microliters of my sample of each sample to each designated tubes, making it a total volume of 200 microliters. I'm going to mix my pipetting up and down. So when you're done adding your samples, the next thing to do is, to my standards, I flick. I can either flick or vortex, but I always prefer flicking. It's also another way to vortex. And avoid as much bubbles as possible. And my second standards, I do the same. Then the next thing is to centrifuge. So when you're done centrifuging, the next thing to do is to standardize the Qubit machine. Since I'm using the 1x double-strand DNA high sensitivity working solution, I'll click the first option, read standards. So it says insert standard 1, which is the one labeled B, the standard labeled B. So it reads it. I'm going to add the second standard. Then the next thing I'm going to do is to run my sample. I'm going to click on run sample. So since I added 2 microliters of my sample to the working solution, I'm going to increase this to 2 microliters, Then I'm going to place one of my sample tube. Which has been flicked and centrifuged. So tube. So here it says my sample is too high. So I'm going to read my second sample. So here it rates 43 nanogram. So due to my working solution, the range is high sensitivity working solution, and the range is usually between, I think, 0.1 nanogram to 120 nanogram. So if your let's say extracted DNA nucleic acid solution, or your amplified DNA is if it's above that limit, it's always going to show you the error message that your sample, the concentration is too high. And if it's below the range, it's also going to tell you that your sample is below the limits of detection of the machine. So now we are done.